So now we're going to talk about the last part of ionic compounds, and that is the transition elements. If I come over to the periodic table that we've been working from, that is going to include these pink ones in the middle. These are ones that can have different charges depending on what it's combined with. So it's really important to understand which elements you have to know the charge of or are always the same and which ones are variable. So one example is iron. Iron is element number 26, and it can either have a +2 charge or a +3 charge, meaning that it can give up 2 electrons or 3 electrons, depending on its partner. So we denote that by using Roman numerals. You can see here that if it has lost 2 electrons, we give it a Roman numeral 2. If it's lost 3 electrons, then we give it the Roman numeral 3. So those Roman numerals are indicators to you exactly how many electrons we're talking about. And at the bottom, you can kind of see a few examples of that. So for example, if I had Fe2, well then that tells me that that iron has 2 electrons to give. If I'm combining it with Cl, then that means Cl normally has a -1 charge. So I'm being told with this information here that Fe is a 2+, and I'm trying to combine it with Cl, which I know is a negative. So using our crisscross method, I can make the formula FeCl2. And that tells me that Fe must have a +2 charge to kind of balance out the -2 charge of chlorine. And if I'm going to name it in words, I'd say iron 2 chloride. For the transition metals, you actually have to include the Roman numerals. When we were learning about this before, we didn't have to include that because they always kind of follow a set pattern. For the transition metals, however, you need to specify because that would change the formula, as seen down here. So if iron was a +3, meaning that it happened to have 3 electrons to give, and I'm trying to combine it with Cl, then I would end up with FeCl3. I would need an additional chlorine to kind of balance it out. So then that one would be called iron 3 chloride. So the only difference is the Roman numeral, and then that tells you in words which one of the two formulas it happens to be talking about. So let's do a little bit more practice here of how that might look. So copper 2. It's basically telling you right away that it's Cu +2. Copper 2. So with that said, if I'm combining it with chlorine, I know chlorine is always a -1 and oxygen is always a -2. If it helps to put those things in there, then please do so. Scrolling across the top, you can even do the same. This is the Roman numeral 4, so that tells me that this one is going to be +4 or +3 or +3. So whether it's in a superscript or a Roman numeral, it's basically giving you the same information. And you do just like what we had been doing before. I would have Cu, and then I would need 2 Cl's to balance. If it helps, you can draw them out and do the crisscross. I'll do that on this one here. So you have Cu +1, Cl -1. You could do the little crisscross method if it helps or you get confused at any point. But this one, I only need one of each. Same thing here. There's AgCl. Tin has 4. So tin as an element symbol, I need to look up because I never remember, but it's Sn. It's one of those weird ones, right? Has a +4 charge. So that means I'm going to end up needing 4 chlorines to balance that out. Nickel is a +3, so I'm going to need 3 chlorines to balance it out. And Au is a +2, so, I don't know why I did Ag. Yikes. Let's pretend that didn't happen. So Au is a +2 will balance out with chlorine if I have 2 of them. Then kind of going down to the next row with oxygen, copper has a +2, oxygen has a -2. So that works out just fine. Ag is +1, so I'm going to need 2 of them to balance out oxygen. Tin is a +4, and oxygen is a -2. So kind of utilizing that crisscross method, I would end up with SN2O4. You could also simplify that if you want and make it SNO2. These two are kind of both the same thing. This is just the more simplified version. Nickel is a +3. Oxygen is a -2. If we crisscross, we end up with nickel 2O3. And AuOFe2O3. This one here with iron would be similar to what nickel is because of the similar charges. So hopefully that gives you an idea of how we could put those together. Moving on, now we're going to have to try to name some of these, and this is where it might get a little bit tricky. So starting off with the very first one, I have SN, which we learned is tin. So I know that I'm going to have tin, and I know that I have bromine, or in this case, since it's an ionic compound, it's going to be bromide. So bromide normally has a -1 charge, and I happen to have 2 of them. So together, I kind of have an overall of -2. Since each one is a -1 charge, when I have 2 of them, collectively that's a -2, which means collectively tin has to be a +2. So I already know by looking at the formula that it has to be tin 2 bromide. It has to have a positive charge to balance out the 2 bromides. Whereas here in part B, I do know I still have tin, something, and I do know that it's still bromide. That part doesn't change. But here I have 4 bromides, or bromines. So collectively, they have a -4, which means this one over here has to have a +4 to balance it out. So they're both tin bromide, but one is tin 2 and one is tin 4, based on how many electrons they have. Next up, we have chromium. So Cr is element 24, chromium. And then oxygen turns into oxide. So since there's one of each, oxygen normally has a -2 charge, which means the chromium must have a balanced 2 charge to go with it. Down here, the last one, again, I have chromium. So that doesn't change. And I still have oxide. But now I need to figure out what the charge is on the chromium. So each oxygen is -2. Collectively, I end up with -6 worth of total charge. I have 2 chromiums, and I need to have a balance. So I need to somehow get a total of +6. So that means that each chromium must have been 3 to make that happen. So I end up with chromium 3 oxide. And the last page of practice is basically taking the words and turning them into the formula, which I think is actually easier than what we had just done the other way around. So chromium, we've been talking about now, is Cr, and it's telling me that it's got like a +3 charge. It's telling me it's chromium +3. And I know that chlorine normally has a -1. So if I'm trying to put them together, following the same suit we've been doing, I would know that it's going to be 3 chlorines to balance out the chromium. Tin, Sn, I know in this case, thanks to the Roman numerals, it's 4. And then oxygen normally has 2. Again, you can crisscross if you like. It ends up being SN2O4. You can simplify it because both of those divide by 2 to SNO2. Lead. Lead is Pb, so that's another weird one. I'm being told it's +2. Oxygen is -2, always. So I just need, oops, I got a little excited on the Pb, I guess, and I created them together. So you only need one of each in this instance, PbO. And then finally, copper is Cu, and it has a +2 charge. Iodine has a -1 charge. If we cross multiply, I end up needing 2 iodines to balance out the copper. So I hope that it's now a little bit easier to figure out how to do this piece.